This is Note-Taking Guide 1.6, Factoring Cubics or Special Patterns. The first thing I want to do is talk about what a sum of a cube or a difference of cubes would look like. So if we were to see that, we would see a perfect cube number added to a perfect cube number, or a perfect cube number subtracted with a perfect cube number. So what numbers make perfect cubes? Well, 1 times 1 times 1 would be a perfect cube. That perfect cubed would be equal to 1. So 1 times 1 times 1 is equal to 1. So 1 is a perfect cube number. 2 times 2 times 2 is equal to 8. So 8 is a perfect cube number. 3 times 3 times 3 would be 27. So this is the way that we find our perfect cube numbers. Okay, with variables, a perfect cube number would be a number that there was 3 of. So if you had y cubed, that would be y times y times y. Or if you had y to the 6th, that would be 2 sets of y cubes. So we're going to look at these monomials really fast and we're going to decide if they're perfect cubes or not. If they are perfect cubes, I'm going to tell you a couple of their cubed roots. So 64y cubed, this is a perfect cube because 4 times 4 times 4 is 64, and y times y times y is y cubed. So 4y would be its cubed root. 30z cubed is not a perfect cube, but 27x cubed is. 27 because 3 times 3 times 3 equals 27, and x cubed because x times x times x equals x cubed. 9x cubed looks like it's going to be a perfect cube. That 9's deceiving though because it's not a perfect cube number. It would be a perfect square number. Another perfect cube number would be 8y to the 6th because it's 2 times 2 times 2, and y squared times y squared times y squared. So we'd have y squared here for our cubed root. 125m cubed is perfect cubed because its cubed root would be 5m. 216 x to the 6th is a perfect cubed. And then 8x to the 9th is also a perfect cube. And then there's just one more problem, a couple more problems over there that we are having a hard time seeing. 100 is not a perfect cube, but this one over here that you can't see says x cubed, y cubed. It also is a perfect cubed because it would cube root to x times y. So the two formulas that you see before tell us what to do when we see a perfect cube. What the formula says is if you see two perfect cubes with a minus sign in between them, cube root them and throw them through this big long formula right here. Same thing with the sum of cubes. If they're added together, you're going to put them through this formula, and I'm going to show you how to do that. So the first problem here is x cubed minus 8. This is a perfect cube. It's a difference of cubes actually because this number is a perfect cube and this number is a perfect cube, and there's a subtraction sign. So the difference of cube formula says to do a minus b and then a squared plus ab plus b squared. We need to identify our a and our b. Our a comes from the cubed root of the first number. Well, the cubed root of x cubed would be x. And the b comes from the cubed root of the back number. The cubed root of 8 would be 2. So then it's just a matter of substituting it into the formula correctly. So a minus b would be x minus 2 because of our substitution there. A squared would be x squared plus ab, so multiply those two together to get plus 2x, and then the last part is b squared, and b squared would be 2 squared, and 2 squared would be 4. So this is actually factored form of that perfect cubed. Same thing here again, looking for our a and our b value so that we can go through our perfect cube formula. Our a value comes from the front, its cubed root is 3. The b value comes from the back, its cubed root is 4. And then you're going to plug it through the formula. Because this had a plus sign in between it, our formula starts with plus, a plus b, then a squared minus ab plus b squared. And we're just going to substitute our numbers into that formula. So we'll have x plus 4 x squared minus 4x plus 16. The 16 comes from squaring the b value. The b value was 4. 4 times 4 is 16. Here's another one. Same exact thing here this time. We're still going to identify our a and our b value. Our a value here is going to be the cube root of 27x cubed, which is going to be 3x. And the b value comes from the back, which the cube root of 1 is 1. This has a plus sign in between it, so I'm going to use my formula that has the plus sign in between it. It's a plus b, then a squared minus ab plus b squared. And again, it's a matter of substituting my numbers in there. So every time I see a, I'm putting 3x. Every time I see b, I'm putting 1. So I'll have 3x plus 1. And then I'm going to have 3x squared. I'm taking this whole quantity and I'm squaring it, which means I'm going to have 9x squared here, minus 3x times 1, which is 3x, and then plus b squared. Well, 1 squared is 1. Another very similar problem here. Still going to identify my a and my b value. My a comes from the cubed root of the 8x squared, which is 2x, and my b comes from the cubed root of 1, which is 1. I follow my formula. It has the minus sign first because there was a minus sign in my problem, and then the rest of the formula is a squared plus ab plus b squared. And I substitute in. Every time I see an a, I'm putting 2x. Every time I see a b, I'm putting 1. So I have 2x minus 1. Then I have to square the a value. The whole thing squared would be the 2x squared, which is going to be 2 squared, which is 4, and x squared, which is 2. X squared with a power of 2 on it. I'm going to multiply my a and b together to get 2x, and then b squared would be 1 squared, which is 1. We're getting done here, but we have a couple more examples. Still identify your a and your b. Your a in this case would be 5x because it's the cube root of 125x cubed. Your b would be 2y because it's the cube root of 8y cubed. We're still plugging it into our formula. The minus sign's coming first in this one because our sign up here was minus. We'd still have a squared plus ab plus b squared, and we're just going to sub it in. So 5x minus 2y, square that a value so you get 25y squared. Do a times b to get 10xy, and then plus b squared. You're going to square that whole value there, which is going to be 4y squared for your solution. One last one right here. We're going to cube root again to find our a and our b value. Our a value would be 3x because it's the cubed root of the 27x cubed. And our b value would be 6y because that's the cubed root of 216y cubed. Plus sign here, so ours has to start with a plus sign. And then our rest of our formula would be a squared minus ab plus b squared. Substituting 3x in every time you see an a and 6y in every time you see a b. So 3x plus 6y. You're going to square the whole a term, which is going to be 9x squared, times the 3x and the 6y together to get your minus ab, so a minus 18xy, and then square your b term, which would be plus 36y squared for your solution in factored form.